Well, good evening. You might recall earlier on I bought this 5540B as a parts mule was my original plan. $65 I paid for this. Now, I wasn't able to test to see whether or not it actually works because there was no fuse in it. So I had to go up to Fluke and buy the appropriate fuse holder. Now the fuse holder takes just a little glass 3AG fuse here, I think is the series, and you just drop that in there, and that's going to plug into the back of the unit. So let's swing this around and put this in, and then the moment of truth. It's like they said in the auction it didn't power up. Now, when I bought my previous one and I put the fuse, it also is missing the fuse. When I stuck the fuse in, they were right, it didn't power up. I wonder if this is the same. It was a problem with the DC to DC converter on the display panel here. So let's go stick the fuse in and see what happens. Okay, now you can see this is the little fuse holder here. So let's drop the fuse in, put that in there, and then I should be able to just lock that in. There we go. Let's plug in a little power cable, and now let's turn it around so we can see what it looks like. Let me get it angled again so that we're not getting the light on it. And here we go. Drum roll, please. And what do you know? It's a little dark. Let me see if I can zoom in so you can see that you can see that it's coming up voltage mode. I'm not hearing a fan though. This also doesn't mean that it actually works. It just means that it's turned on. Let's grab my bench scope and set it up, and we'll see if we get any voltages. Be right back. Okay, here we are. We're turned on. So it says voltage mode. I have it set up here. I have this plugged in. So let's just go in and let's move the cursor. I have it set. It's set for millivolts. There. Let's go in and put 5 volts on it and turn operate on. And what do you know? You get 5 volts there. Let's try minus 5 volts. Okay, minus 5. Hopefully you're able to see that in the display there. You see that I have this. Let's go over. I have this set for 5 volts. These vacuum fluorescent displays can get quite dim as they wear down. Still not hearing a fan. That's interesting. We're getting 5 volts now. Let's try 100 volts. And it'll drop back into standby. As you change some big voltages here, it'll drop the unit into standby so that you're not accidentally going to arc yourself up. So let's turn it on. And that's, good. Let's try minus 100. Interesting. Now, I haven't run through the calibration here. We've just turned this on. Let me pause while one of the things that you should always check before you go high voltages is whether your multimeter can do it. Now I think I'm good on this up to 600 or 500 volts, so I want to just check and make sure what my upper limit is before I set it too high. Okay, so the limit does say that it's good to 500 to 1000 volts, so let's take it to 500 volts. Wow, look at that, 500 volts. Let's try minus 500. Okay. Should we do it? Yeah, let's take it to 1000 volts. I need a new 6.5 digit meter. Anyway, let's take it to 1000 volts. Look at that. Probably a bit on my meter, a bit on the cables. Let's take it to minus 1000 volts. Hear the relays going around. Wow, minus 1000 volts. Alright, let's turn that off and go back to 1 volt. That's pretty cool. I think there might be a problem because I think the unit's supposed to have a fan in it. I don't remember. We'll have to take the cover off and have a look and see why the fan isn't, if there's a fan and why it isn't running. And then we can let it warm up. Why don't I take my, let's take this out and let's swap in my 3458A and get a real good look at what the voltages are. Be right back. Alright, so here I have my 3458A metrology grade 8.5 digit multimeter, and it's recently been calibrated by Keysight. I wanted to get it to extended warranty, the 3-year warranty on it, just in case anything happened, and part of that, what you have to do is go send it in for calibration. The guys at Loveland, the facility there in Colorado, are absolutely fantastic. You can't find a better bunch of guys when it comes to treating customers right with these type of meters. So this should be pretty much bang on in terms of the value. Now, when I say bang on, we also need to put this in context that this has only been running for basically as long as the video has been going, and this has only just been turned on as well. So you're supposed to let these warm up. This guy, according to the manual, you're supposed to give a 2-hour warm up to and then run the auto calibration procedure. This guy you're supposed to let warm up for an hour or so and then do the same thing, run the auto cal. Not going to do that because I'm just intrigued to see how accurate things are just cold. So let's go in. We have it set for DC volts. You know, let's go set 1 volt here. Let's hit enter and let's turn it on. And right out of the gate, you're looking at 1.0000 volts. That's pretty good for no calibration, no warm up, no nothing. Let's try 10 volts. You're looking at 10.000025. Again, not too bad. Let's try 100 volts. Let's go on into standby. Let's turn that back on. Now this is no sense cable set up. We're just using the basic connectors here. You know, so we're going to lose a little bit of voltage, but you know, that's not too bad. Let's try 500 volts. That's pretty good. Let's try 1000 volts. That's pretty damn good in terms of the performance of the thing. Just out of the box, no warm up, no nothing. Now there's significant error, you know, if you did the math, but in terms of like what I was expecting when they said the thing didn't work, I was expecting that there'd be virtually no output. All right, let's take a quick look inside and see what's going on with that fan. Let's set it back to 0 volts so that no one actually, I'm not dying of anything when I touch it there, but let's go have a look and see what's happening with that fan. Okay, so there's our fan. Let's just because this is all the power supply over here, so let's just take that out for the moment and then just see if the fan, oh, that's a horrible feeling fan. There's like you can sort of hear the grinding. Alright, well, let's plug this back in. Let's go and turn this on. Okay, that fan should be going. Yep, well, I'm not getting anything on that fan. Let's turn this guy off. And let's see what we can learn about where that fan is plugged in. It's soldered right in at the bottom there. Let's see if we can zoom in and see it. You can see that let me grab out a little spudge. You can see that this black cable here is where the item is. It goes right down to the board down there. Let's come across, see if I can get you a better image in there. Can't quite see it because the darkness, but that cable there, it basically goes down as it's soldered right onto the motherboard down there and then comes into that fan. So this fan is dead and looks like we'll need to replace it. Now I don't know what type of fan that is. Let's zoom back out again. You know, I don't know what type of fan that is, but it looks like it's just a standard everyday PC fan, albeit a little bit thicker. Let's just go in and measure what the different distance is between the mounting points. You know, it's like I don't know how you actually measure these. These are like, it's like 105 mil from point to point. I wonder how they actually do it. Do they do it across when they measure the fan? So they do it across the fan? That's a great question. Let me go check. And there you go. The standard 120 millimeter fan has 105 millimeters between the screw holes, and so that's what we've got. So that's really just a standard everyday PC case fan, probably. So I wonder what the power is. Probably just the standard fan. So we'll have to have a look at the schematic and see what it says. Okay, taking a quick look at the schematic and the theory of operation. This is actually 115 volt fan, and so it should be running right on the ground there. That's where it's coming off one of the taps of the primary transformer, which is actually down there attached to that. Here, let me not poke it with my finger, but with a non-conductive item. This guy down here is the primary transformer, and this is permanently connected to one of the primary side taps here. So it's a 115 volt fan. So I'm going to have to get a replacement fan for this unit and see if I can find one that will work. I'd like to do that before I left this guy sitting on for the 2 to 4 hours that it needs to warm up. Anyway, I think we might have, apart from the fan and the missing power supply, we might have something that's very close to a properly working unit. I just took the back, these little covers off, and actually, now that I look at it, if you look at the cover, what's gone on is that the cover has actually been pushed into the fan, and so that was stopping the fan from spinning around. So I just took this off, turned it on. We're now getting the fan there. So I'll go flatten this out. We'll put this back on, put the top on, and we'll leave it sit for 2 or 3 hours, and then warm up, and then we'll do an auto cal. Okay, I wanted to keep giving you a little bit more insight into how the systems work here. You know, I just brought them up this morning while I've been checking my email. They really should sit for probably another hour and a half or so to keep warming up. But they've been on for about an hour, so we should see a reasonable voltage here. So if I come in here and I set 10 volts and hit enter, you know, we'll see the 10 volts over here, and if I turn it on to operate, we'll see that it should settle down to, you know, pretty much 10 volts there. And we can see that across the board. If I go in and select 100 volts and then tell it that we want to look at that, you know, we're going to see a value close to, you know, 100 volts. If we go in and select 1000 volts, we should see a voltage come in very close to, you know, like 1000 volts. So overall, I'm pretty happy that this seems to be working. Now, let me show you how you might use this. So I'll just reset the system here, and let me take out these cables, because what we're going to go do is we're now going to go and calibrate. Effectively, let me just let's just take these completely out. We're now going to go and calibrate my Rigol meter that I have sitting on the top here. Now, I'm not using great cables here, but you're supposed to, you should use good quality low EMF cables so that you get you know, so that you're getting very, very accurate measurements. I have some of those cables on order, and they should be arriving sometime by the next few days. But for the purpose of this video, this will do well for us here. So what I'm going to go do is I've got my item hooked up, and I have, wasn't even thinking. I have the external sense set up, and so for those of you, if you're not familiar with it, the concept of the external sense is like a 4-wire ohm measurement, but applied to voltage. What it enables the system to do is supply the voltage out of the main supply lines, and then sense its voltage at this point, and that hopefully will get rid of the cable loss. Now, for very accurate measurements, what we should be doing is actually having twisted cables and all that sort of thing. But for the purpose of this video, I'm not going to bother with that. So now I have this, you know, I would go in and I could go in and set 10 volts, and I could turn it on, and I could see what the voltage is on my meter. Now, what I can work out is, because this would be highly calibrated, I can get there and go, okay, well, I want this to show 10 volts. So what I can do is I can use these keys to move this value around, and you can see that the value will change there. And so, you know, I think I need to like just increase this a little bit here, you know, and so you can see that as I go up, you know, it's starting to get me to 10 volts there, and there you go. So what I would be able to say is, let's go up a little bit there. You know, I'd be able to say roughly that, you know, this meter reads 10 volts when it's being fed 10.00095 volts. Now I could then grab, you know, I could grab my DC characteristics sheet, and I could work out and see what the values are. But one of the cool things about having a proper calibrator is it gives you an ability to go in and set these up automatically so that it will actually tell you. And this unit here has a thing that's called error mode, and if I hit error mode and we look down here, it enables me to turn on the error mode, and then it will tell me what the actual error is, and I can set that by coming up here and entering a error tolerance. Now it just so happens that for, let me reset the unit so that we're all back to normal. Let me go to error mode again, set the error tolerance. It just so happens that for, if we're looking at 10 volts, you know, I know that the error range is 0.015% of the reading, and then I know that it's also going to be 800 microvolts according to the specs of the unit. And so now if I set 10 volts and I press enter and I turn it on, and let's turn on external sensing, you know, we'll see that we get 9.991, and because I have 10 volts here, we've got 0 ppm error. And you can see, let me move those out of the way, you can see, yeah, let's try and get a better view there. I don't know where I'm going to put those so that you can get a good view. You can see that I'm getting 0 ppm error, and then the system is actually telling me that it's a pass, so that I know I've passed. Now, remember I could use these because I want to scroll this in. So I'm going to come in and I'm going to say, okay, let's go up one, and then let's go down, you know, a little bit, and there we're on. And now if we look over here, we can see that our error is, you know, minus 90 ppm, but for this unit, based on the specifications, that's a pass at 10 volts. So that's something that I can go do. Now when I set this up, you know, one of the cool things with the B unit, and this is different from the B/AF, which is my other unit that's up with Fluke for being getting manufacturer calibration, is I can create a little program here. So, you know, the first the first thing that I might want to do is set 1 volt, right? And let's just assume that my error values all stay the same. So with 1 volt, that's what I'm going to measure. So what I'd want to do is I can just go in and say, let's add this as a step. And then I can go in and say, let's go and maybe make 10 volts. And I can enter that, and I can set the unit up, and I can add that as a step. And then later on, what I can do is I can come back and I can say, let's select step 11, which was the one that I just put in, and you'll see that it resets the value here and resets the unit. So this means that what I can do is I can quickly set up a set of tests that I want for my unit here, and then I can actually save these to the memory module. So let me just go in and clear the memory right now, and so if I go on select step and try and select step, if I select step, you'll see there's no sequence in there. Now what's gone on is this is actually being stored on this little procedure storage module. We had a quick look in here before, but what I can do is I already have created a set of steps here. So I'm going to go from module to memory, and it's read that in. So I'm going to select step 1, and here you'll see that I'm set for 1 millivolt, and I'll have already set, if I go into and have a look at my tolerances, you'll see I've already set the tolerance level here. So now I can go on my 1 millivolt, I can come in and, you know, bring that down. We're right at the bottom here, you know, so we're pretty accurate on 1 millivolt. And now I can go along to the next step, which in my particular case is 100 millivolts. And so now I'm looking up here, and so I can bring that up a little bit more. And then I can go, okay, now we're at 4, so we're 40 ppm, but we're still a pass. Let's go to my next step. I want to check 1 volt now. And so once this settles down, I can, you know, come across and maybe bring it up, you know, a little bit, you know, and now I'm now reading 30 ppm, and so on. I can go next step, which, you know, here is 2 volts, you know, next step 10, 20, 100, and do that same process. And at the end of this whole process, what I will have gotten is a set of values for whether or not my unit is actually in calibration. So this makes it really easy for you to go in and generate or go and calibrate meters, especially for DC. Well, this is DC only. Go in and calibrate these meters, because you can set all this up and then store that there. So I hope you found some of the operation of this interesting, and I'll catch you again later.